Welcome back to our third installment in our discussion of databases and database users. We left off talking about a number of the functions and responsibilities of a database management system. Now let's take a look at an example of a typical database management system. Let's consider an example that you may be familiar with, a university database for maintaining information concerning students and courses and grades in the university environment. The database is organized into 5 files, each of which stores data records of the same type. The student file stores data on each student. The course file stores data on each course. The section file stores data on each section of a course. And the grade report file stores the grades that the student receives in various sections that they have completed. And finally, the prerequisite file stores the prerequisites for each course. I use the term file loosely here. A file actually refers to a physical structure stored on some form of secondary storage. For example, a file could be a Word document, it could be an Excel workbook, or even a database file that holds all of the items that we've just described. At the conceptual level, though, a file is a collection of records that may or may not be ordered. To define this database, we must specify the structure of the records for each file by specifying different data types of data elements stored in each record. For example, each student record includes data to represent the student's name, the student's number, the class such as freshman or sophomore and so forth, the major such as math or business or computer science. Each course record includes data to represent the course name, course number, credit hours, and department. Department refers to the department that's offering the course, and so on. We must also specify the data type for each data element within a record. For example, we can specify the student name as a string of alphabetic characters, the student number as an integer. By doing this, that allows the database to automatically increment the student number when we add a new student, taking some of the burden off the users of coming up with student numbers. The grade of grade report is a single character from a set of A, B, C, D, or F. We won't have any F's in this class. We may also use a coding scheme to represent the values of a data item. For example, the class of a student. We're a student. You're a student. The class of a student can be a 1 for freshman, 2 for sophomore, 3 for junior, 4 for senior, and 5 for graduate student. To construct a university database, we store the data to represent each student, course, section, grade report, and prerequisite as a record in the appropriate file. Notice that the records in the various files may be related. The design here is that of a relational database. For example, take a look. Here's the student file, and there is a student number that represents Mr. Smith here. All right, take a look over here in the grade report. Here is that student number again, and here's that student number again. As a matter of fact, there's Mr. Smith's number. And then there's a section identifier. Well, look over here in section. There is the section identifier. You can see how these records are related by this common information. And you can also see how it would be possible, for example, to generate a report on all the courses that you are taking this term by combining these together using that related information. The design being used here is that of a relational database. There have been several different approaches to database design over the years: hierarchical databases, network databases, and relational databases. The hierarchical database is a design that uses a one-to-many relationship for the various data elements. Hierarchical database models use a tree structure that links the different elements to one owner or parent or primary record. Another of the early models is the network model, which allows each record to have multiple parent or child records, forming a generalized graph structure. The network model was eventually displaced by the relational model. As hardware became faster, the extra productivity and flexibility of the relational model led to the gradual obsolescence of the network model. Early on, the relational model had difficulties due to the performance of the hardware of the day, the microprocessors, the memory, and the other electronic components that were found in computers. They just weren't fast enough to handle the overhead required by the relational model. But as the hardware became more powerful and faster and capable, the network model became obsolete. In fact, why don't we make the network model our mystery word for this installation? The network model. Essentially, the relational database model connects the various tables and files together by those common data elements as we just talked about. It is the flexibility that's made the relational database the dominant model. Here are some of the issues about relational databases. There are relationships among the records, as we've already seen. Manipulation of these databases involves querying and updating the records. Some examples of queries: print out your transcript, a report to list the names of students who took a particular section of a database, a list of prerequisites for a database. All of these are the various kinds of queries that one must run using a relational database. Why don't we take another break here? Before you leave, go down and answer the mystery question so that you can get credit for it, and then go out to coursework and do the Check My Knowledge on this installment of our series of videos on databases and database management systems. And when you're ready to come on back, there'll be another installment waiting for you.